Let's go over homework for section 7.2c. This is a volume of known cross sections. So 61. We start off finding the shaded region. So we have y equals x plus 1. That's the parabola here. I'm sorry, that's the linear equation here. And y equals x squared minus 1, that's the parabola. And we see the shaded region is the enclosed region that we see here. And they're telling us also how to draw these bases perpendicular to the x-axis. So x-axis is horizontal. Perpendicular means 90 degrees. So this will be going vertical. And we're going to draw the base from the top graph to the bottom graph. And so now this will represent the base of the shape that we're concerned about. So the shape that we're concerned about is going to be a square. So we do top minus bottom. So the top of this length is hitting the x plus 1. The bottom of the length is hitting the x squared minus 1. So we do top minus bottom, and we simplify this to give us x minus x squared plus 2. Okay. We also need to find the bounds. So to find the bounds, we need to, so just like how we would with washer, disk method, or finding area, we have to find in terms of x. So we set the parabola equal to the linear equation. Bring everything over to 0, solve for x, we get negative 1 and 2. Hey, we're creating a square, and if we draw a square here, we're going to have the base being x minus x squared plus 2, and then we're also going to have the height also being x minus x squared plus 2 because we're dealing with a square. And the area of a square is simply base times base. So we simply plug this into our formula. So the formula that we're using is the volume is equal to the definite integral of the area of the cross section times of dx. So base squared, so that will give us x minus x squared plus 2, quantity squared, from negative 1 to 2. And we can plug this in our calculator, or we can go through power rule to expand. And we're going to get 81 over 10 cubic units. Again, notice there's no pi in our answer because we're no longer dealing in terms of washer or disk method, having to use area of circle formula. Okay, part B. We have the same shaded region, but now this base is going to represent the base of a rectangle. Okay, so we're trying to find the volume of a rectangle of height 1. So we can draw a rectangle here, the base being x minus x squared plus 2, the height being 1. And if we think about the formula for area of a rectangle is simply base times height. So base times height, anything times 1 is just going to be itself. So when we plug into our formula, everything will be the same because, well, the bounds will be the same. Everything will still be in terms of x. We're still using vertical lengths that is perpendicular to the x-axis. So we can plug this in our calculator, or we can go through power rule, and we're going to simply get 9 over 2 cubic units. All right, let's look at number 62. We have formula for area for a circle. X squared plus y squared is equal to 4. And part A is, and these are going to all be perpendicular to the x-axis. So here's the x-axis. So again, we're going to do top minus bottom. And when we do that, we have to identify the equations of both of these functions. Okay? We're doing top minus bottom, so we have to make sure that we solve in terms of as y equals, and we get everything in terms of x. So when we solve for y, we're going to get y is equal to plus or minus the square root of 4 minus x squared. And the positive square root will be the portion that is above the x-axis. The negative square root will represent the portion that is below the x-axis. So once we draw our length, which will represent the base, we do top minus bottom. So the top of this length is hitting the positive square root of 4 minus x squared, and the bottom of this length is hitting the negative square root of 4 minus x squared. So square root minus a negative square root, we end up adding it because the two signs cancel out. So the length of the base of this square will be 2 root 4 minus x squared. So if we know the length is 2 root 4 minus x squared, we know the height is also going to be the same value. And we have to look at our bounds from the furthest left to the furthest right. This is a circle with radius 2, but we can also set the equation equal to 0. And if we solve for x by setting the equation equal to y equals 0, we're going to be able to get to negative 2 and 2. But you can also pick this out by looking at the graph. So lower bound being negative 2, upper bound being 2, we take the base and we square it, and we can go through power rule to expand. We're going to get 128 over 3 cubic units. Okay. Part B, all these we're going to be using the same base because it's going to be the same shaded region and oriented the same way, perpendicular to the x-axis. So we simply look at the base and we plug it into the respective equations to find the volume of the cross-section of that particular cross-section. So the base is 2 root 4 minus x squared. We picked this from the last from part A. So here's our equilateral triangle. Okay, all the lengths are going to be the same, and the formula for the area of an equilateral triangle is root 3 over 4 times base squared. So my base is simply going to be 2 root 4 minus x squared. I can pull the root 3 over 4 on the outside. This is going to be a coefficient, and I can simply just evaluate this, plug in the calculator, and that'll get us down to 32 over 3 root 3. So we find the value here, multiply it by root 3 over 4, and we can simplify. We can get an estimation there to be 18.475. Okay, part C, we have semicircles. So now the base will represent the diameter of a semicircle, and we have a formula that is written for the diameter using diameter instead of radius, which is pi over 8 diameter squared. So my diameter is now going to be represented by the base, 2 root 4 minus x squared. We can pull the pi over 8 out. The bounds are still going to remain the same from negative 2 to 2, and this will reduce down to be 16 over 3 pi. Okay, and finally, part D, isosceles right triangle with the hypotenuse on the base, and with the base being the hypotenuse. And so we have the hypotenuse now representing the base, 2 root 4 minus x squared. The area formula for in terms of an isosceles right triangle using the hypotenuse is 1/4 hypotenuse squared. So 1/4 2 root 4 minus x squared quantity squared. We can evaluate the bounds from negative 2 to 2, and 1/4 2 root 4 minus x squared quantity squared. Plugging our calculator, we can get 32 over 3 cubic units.